All right, so for problem number 52, we want to express this number here as a ratio of integer, and this is just a repeating decimal that goes on forever, so it goes on like this. And now the important part here is to realize that this is actually an infinite sum. And the way that we express this as an infinite sum is to say, okay, this is the same thing as going 0.46 plus 0.0046 plus 0.000046 and then plus 0. So all the previous ones get replaced by zeros, and then we just add another 46 and so on and so forth. And it's the same thing as that repeated decimals, because if we are to add it up, so if we add all this up, that's going to be 0. The first one adds to 4, the second column adds to 6, the third column adds to 4, the next column adds to 6, and then 4, and then 6, 4, 6, and so on and so forth, right? So we can see that this infinite sum, it matches up perfectly if we express it this way. And now let's try to think of how we can express each of these terms, but as a power. Because if we can express this as a power, then that means that we can express this as a geometric sum. So this 0.46, notice that that's the same as going 46 times 0.01, right? And that's the same thing as going 46 times 10 to the minus 2. For the second one, 0.0046, that's the same thing as going 46 times 0.0001, which is the same thing as going 46 times 10 to the minus 4. And the next one similarly is going to be 46 times 10 to the minus 6, because we can see that we have 6 decimal places. The next one is going to be 46 times 10 to the minus 8, because now we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 decimal places and so on. So actually what we can affirm through this is that this sum here is the same thing as the sum of 46 times 10 to the minus 2 times n. So let me write this, 10, maybe I'm going to do it a little bit different. 10 to the minus 2n, right? So 10 to the minus 2n, so when you plug in, and it goes from n is equal to 1 all the way out to infinity, because if n is equal to 1, then my first term is going to be 46 times 10 to the minus 2 times 1, so 10 to the minus 2, and then, which is the same thing here. If n is equal to 2, it's going to be 46 times 10 to the minus 2 times 2, so 10 to the minus 4, which is the same thing as there. And then if n is equal to 3, that would be 46 times 10 to the minus 6, and then 46 times 10 to the minus 8, and so on and so forth. So once we have this, we're just going to improve it a little bit, because we want to get it to the geometric form of the formula, rather, so that we can use the summation formula. So to do that, what we're going to do is, so that's n is equal to 1, infinity, that's going to be 46. So that minus 2 is going to go inside the parenthesis, so that's going to be times 10 to the minus 2 to the power of n. These are the same thing, because when you raise to a power, you just multiply, and that's going to be the same thing as, from n is equal to 1, 100 times 46, and 10 to the minus 2 is just 1 over 100 to the power of n. So once we have rewritten this, we have arrived at this form here, and this matches the geometric formula, the geometric series formula, which goes like this. If you have the sum from n is equal to 1 to infinity, this is given of a times r to the power of n. This is given by a sub 1 over 1 minus r if the absolute value of the ratio is less than 1. So if this thing that's being raised to the power of n, if the absolute value of that is less than 1, then it means that the total sum can be described as a sub 1, so the first term, divided by 1 minus r. So once we're here, let's identify what's what. So we can see that the a, which is this constant that's multiplying everything, that's 46 over here, so that matches up, right? So we can affirm that a is 46. What else can we affirm? We can affirm that the ratio, so the thing that's being raised to a power of n, is 1 over 100. So 1 over 100 is the thing that's being raised, so that's the ratio. So r is going to be 1 divided by 100. And what else can we affirm here? We need also, to plug in the formula, we need a sub 1. And remember that a sub 1 is the first term. And we have here that a sub 1, so the first term happens when you plug in n is equal to 1. So if you plug n is equal to 1, that's just going to be 46 times 1 over 100 to the power of 1. So that's just 46 over 100, right? So let me write this. And a sub 1 is equal to 46 over 100. So we're almost ready to use this formula over here, which is the summation formula. The only thing that we have to check is if it meets this condition. Does the absolute value of r, is the absolute value of r less than 1? And it is, because r is 1 over 100, and that's definitely less than 1. So once we have established that it does converge because of the ratio, we're now ready to plug it in. So now we can say, okay, this whole thing is going to be a 1 over 1 minus r, which is the same thing. So remember, a1 is 46 over 100, so that's 46 over 100 divided by 1 minus r, and r is going to be 1 over 100. So 1 minus 1 over 100. And that's our sum. So all we have to do now is we have to simplify. So on the numerator, that's going to be 46 over 100. And on the denominator, 1 minus 1 over 100, that gives us 99 over 100. So once we're here, we can go ahead and cancel out the common denominator that they have. So the 100 cancels out, and that just gives us 46 divided by 99. And so if you were to plug this into your calculator, 46 divided by 99, you would see that that would be the same thing as 0.4646, and so on and so forth. So that is it for problem 52. So let's just take a step backwards so that we can look at the whole process. So the first thing that we did was we realized that this 0.46 repeating, that's just an infinite sum. It's an infinite sum of 46. But each term gets pushed out 2 units, 2 decimal units, right? So pushed out 2 units to the right. So that's 0.46 plus 0.0046 plus 0.00046, and so on and so forth. And we saw that, wait, that's just the sum of 46 times 10 to the minus 2n, because the power, it increases by evens, and evens is 2n, right? Increases by evens, but on the negative. So once we did that, we just rewrote this as 46 instead of going 10 to the minus 2n. That's equivalent to 46 times 1 divided by 100 to the power of n. And once we did that, once we got over here, we could compare that to the geometric formula. And we saw that a is 46, r is 1 over 100, and it does converge. So once we've identified everything, we just put it in the formula, a1, which is the first term, which in our case is 46 over 100 divided by 1 minus r, so divided by 1 minus 100, and the end result is 46 over 99.